It's our last lesson in our radical unit, and today we're going to be solving radical equations. Now, a radical equation is an equation that has a variable inside the radical. And an equation is something that has an equal sign. Okay, so you're going to be solving for x today, and your x is going to be located underneath the square root or the radical symbol. So this first little question here says, which of the following is not a radical equation? Well, radical equation, the variable's got to be underneath the radical. So on A, it's underneath. On C, it's underneath. On B, notice the x is not sitting underneath the radical. So B, that's not a radical equation. D definitely is, because there's an x underneath the radical on the left side of the equal sign and on the right side. So that one is. So choice B, that's not a radical equation because the x is not underneath the radical. And really, you guys, this doesn't even involve a radical, this equation, because the square root of 4 is just 2. So that's really just 2 plus x equals 9. We all could solve that. All of the others, though, maybe I wouldn't know how to do that until today. So let me show you how you're going to solve something that looks like those other 3 examples. So to solve a radical equation, there's actually 3 steps. And just like we did with dividing radicals, we're going to write the steps at the very end. We're going to kind of like go through them step by step to begin, though. So the first step, and I'm going to highlight that, the first step in solving something that looks like these other 3 A, C, and D examples is to get the radical expression by itself on one side of the equal sign. Now, what is the radical expression? Well, we need to know that. So if I look at these 2 examples here, the radical expression is just what's underneath the radical. So like in A, there's the radical. That's the radical expression, square root x. Sometimes they'll put more than x underneath the radical, like in B. They put 3 times x minus 5, but all of that is sitting underneath the radical, so all of that is the radical expression. Okay, so whatever sits underneath the radical, you have to get that by itself first. So like on A, the 3 and the 8, I would need to move those to the other side. Same thing with B. The 2 and the 1, I would need to move those to the other side before I could continue. That's step 1. So to get these radical expressions by themselves, like I said, we need to move the numbers on the same side of the radical to the other side of the equal sign. So let's do that. I'm just going to copy the problem back down. Let's do A first. So I have to get square root x by itself. So honestly, you guys, don't let the radical freak you out. Like, let's say the radical wasn't even there, and it just looked like 3x plus 8 equals 20. It's the same exact idea. You're trying to get x by itself. I'm trying to get radical x by itself. You guys could all solve this equation. You would subtract 8, then divide by 3. Those are the same steps you take on this. So I'm going to subtract 8 and get 3 square root x equals 12. This just means 3 times square root x, so I just would divide by 3 to cancel that out, and I would get radical x equals 4. The radical expression's by itself now, so I've done step 1. Example B, there's a little bit more, but it's the same idea. I just need to get this 3x minus 5 by itself. So again, just think of that whole thing as like the x value. That's what I have to get alone. So it's kind of the same thing as this. You subtract 1, you divide by 2. Okay, so don't let the mess of the radical kind of get in your way and freak you out a little bit. I would just subtract 1. I'm multiplying the radical expression by 2, so I need to divide by 2. That just cancels the 2. Don't do anything else with it. So now the radical expression is alone, square root 3x minus 5, and it equals 7. So that's step 1. Once you do this, you're still not done with the problem though, because the goal is to solve for x. So I'm not done until I have just a plain x by itself on one side. So example A is almost there, but the radical is over the x, and I need to get rid of that. So think about, how do you get rid of the radical? Well, the operation that undoes square root, just like dividing by 3 undid multiplying by 3, to undo square root, you need to square both sides. So the operation that undoes a square root is squaring both sides of the equation. This is the second step when you're solving an equation that has a radical. Okay, so again, I'm just going to carry down where we ended on both of these examples, taking it step by step here. Example A is a little bit simpler, so I've got the radical expression by itself. Now I just square both sides. Whatever I do to one side, I do to the other. Square and square root just cancel. So I'm left with just x. Oop, didn't need to write that. Oh well. I'm left with just an x on the left side, and on the right side I would do 4 squared. Okay, that's 16. So 16 is my answer to A. For B, same thing. I'm going to square both sides to undo the radical. And let's see, square and square root would cancel, so I would just have 3x minus 5 equals 49. On B, it's a little bit more work because you have to keep going. So if there was something besides just an x under the radical, you just have to keep solving after you square. But we all can do that. I would add 5. I'm not even going to write it because I know you guys know how to do that. It's just a 2-step equation. And then I would divide by 3. So x would be 18. And that would be my answer. All right, let's practice a few. So I'm going to do a couple. I'm going to do 3. You're going to do 1. Now, number 1, let's see, I would just subtract the 7. I've got to get the radical expression by itself, so the square root x. Move everything that's not underneath the radical to the other side. So I would have radical x equals 5. Once the radical expression is by itself, I square both sides to cancel that, and x would just equal 25. You're going to try example 2 on your own. Maybe you want to watch me do 3 and 4 first, though, before you come back and do 2. So example 3, do you see that the 2, the x, the minus sign, and the 3, all of that is underneath the radical? So the mistake people will make, you guys, is they'll go plus 3, plus 3. Divide by 2, divide by 2. Then that's their answer. But you cannot start doing stuff underneath the radical before you get rid of the square root. So everything is underneath the radical on one side. So the first thing I would do is I would get rid of the radical by squaring both sides. So I would just be left with what's underneath. Radical is gone. That would equal 49. Then I could start breaking all that up because there's no radical anymore. So I would just add 3, and then I would divide by 2, and x would equal 26. On number 4, so I have to get, and I'll highlight it so we can all see, that's the radical expression. I have to get that by itself. So the 3 and the 5 need to move to the other side. You're multiplying by 3, you're adding 5. Always undo the adding and subtracting first. So that would be 3 square root x plus 4. I just subtracted 5, so I'd have 12. You're multiplying by 3, so divide by 3. Square root x plus 4 equals 4. Then I would square both sides to get rid of the square root. So I would have x plus 4, I'm running out of room, equals 16. Okay, now I can subtract the 4. And I'm just going to write the answer, subtract 4, so I should get 12. Okay, so make sure you try number 2, see what you get. I'll check it tomorrow when I check your notes. Now, there's kind of one last point to make here, okay? So sometimes there are like special circumstances in these radical equations. So this next example is a little tricky, and let's look at why. The first thing you would do, and I know this already, to solve for x is I would need to get the radical x by itself, the radical expression alone. So I would start by subtracting 8, and I would get radical x equals -3. Now, a lot of us would think, oh, okay, let me square both sides, and let's say I did do that. Square and square root would cancel out, and -3 times -3 is 9. So my answer is 9. Okay, realize that when I got the radical expression by itself, right here, I had a -3 sitting on the other side. Now, think to yourself, can you take the square root of any number and get a negative number? No. When I do the square root of 9, so say I said 9 was the answer, the square root of a number is always a positive number. Okay, so I'm never going to get a -3 when I do the square root of any number. Okay, so I definitely can't ever get that as an answer. So if this happens, then there actually is no solution. Like, nothing's going to work. 9's not an answer because the square root of 9 is +3. Okay, so for that reason, sometimes there's actually no solution. So for that reason, you always have to check your answer. This is the third step. And I'm going to show you a way to kind of recognize the no solution, but just know that you should always check these. So like on your exam, you definitely need to check your answers just to make sure they actually do work. Okay, so let's practice that a few times. The first 2 steps still say the same though. Like I have to get the radical expression by itself. So on number 1, this is the radical expression. Radical 4x. So this +7, I need to move this to the other side. So that I have radical 4x equals 2. Okay, then I would square both sides. Square and square root would cancel out, and I would just be left with 4x. Don't say like 16x squared, don't do that. Square and square root just cancel out, and you're just left with what's sitting underneath. And 2 squared is 4. Now I can divide by 4, and x would just equal 1. I want to make sure I check my answer to see if I actually got an answer that worked. So I'm going to put 1 in where x is, and just make sure this thing equals -5. Well, you would figure out what number sits under the radical first. So 4 times 1 is just 4, and obviously the square root of 4 is just 2. Then I would subtract 7, and yep, that equals -5. So this worked. All right, let's do example 2. Radical expression is the x plus 1, everything that's sitting underneath the radical. So basically I need to divide the -3 over before I can start. And that would equal 7. Now the radical is by itself, so I can go ahead and square both sides to cancel that out. And I'd have x plus 1 equals 49. I would subtract 1, and x would equal 48. And then I'm going to make sure that it works. So I write too big. Hopefully you don't write as big as me. Plus 1 equals -21. You would figure out what number sits under the radical first. So that is 49. The square root of 49 is 7. 7 times -3 is -21. Okay, so that worked. Example 3. This just takes some practice. Here's the radical expression, 2x minus 5. So I'm going to subtract 6 first. And then I've got -2, radical 2x minus 5 equals 10. And then I'm going to divide by the -2. Radical 2x minus 5 equals -5. That's a -2. Right here, you guys, I know that this is a no solution problem. Save yourself work. Let me explain to you. the first step is getting the radical by itself. Okay, so if you look at where you got the radical by itself. So on this problem, here's where the radical is by itself. On this problem, here's where the radical is by itself. On this one, it was right here. If you get the radical by itself and the number on the other side of the equal sign is a negative, like it was here, the radical is alone and there's a -5 on the other side. That's when it's going to be no solution. Because the square root of any number is always a positive number. Okay, so it doesn't matter that there was a 2x minus 5 underneath or an x plus 1, whatever. If the radical is alone and the number on the other side is a negative, stop right there and say no solution. If you don't recognize that and you square it and you keep going, well, that's why we check our answer, just to make sure we don't miss that. But you can save yourself some work. Now, some people will look at the original problem on number 1 and 2 and say, oh, no solution, because look, there's a -5 and a -21 on the right side of the equal sign. But the problem with that thinking is that the radical is not alone on the other side of the equal sign. Okay, so you have to isolate the radical before you can determine that. But recognize that. It'll save you some steps. I'm going to have you guys try 4 and 5. But before you do 4, you probably want to see me do 6 first. Okay, so number 6, notice that there's a radical on both sides, and that on the left side, the x and the 10, everything's underneath the radical. On the right side, everything's underneath the radical. So once I have everything underneath the radical on one, or in this case both sides, I'm ready for step 2, which is just to square. So square and square root cancel. So really this problem, you guys, you can just ignore the radical. If everything is underneath it, it just cancels out. Now I just got to solve this equation. So I'm going to add x and get 2x plus 1 equals 6. Ooh, that's not 1, that's 10. Sorry. And then subtract 10. And I've got 2x equals -4, and then I divide by 2 and get x equals -2. Don't automatically think no solution. I know that that does kind of sound weird. I'm going to check it, though, to see if it works. So, again, I'm running out of room. I'm going to check it down here. Plug in x, -2 right there and right there. So, let's see. I would figure out what number sits into the radical over here. You shouldn't need your calculator for this, but if you do. So on the left side, that's not a perfect square, but it's the square root of 8. On the right side, 6 minus -2, that would be plus 2, which would also be 8. The square root of 8 equals the square root of 8. It's the same thing on both sides, so that actually does check. So I'm good. Okay, try 3 and 4, and let's just generalize the steps at the bottom here. We've gone through it all, but this will kind of be nice to have as you're practicing in class tomorrow. First step is get the radical, which is just everything underneath the square root by itself on one side. Then you square both sides, and then you make sure you check your answer.